Let's try to find the antiderivative of this function. So before we get going and using the power rule, let's try to rewrite everything because we like using the power rule. That's the easy one to remember, hopefully. So what I'm going to do first is just go ahead and bring along that first term. I'm going to rewrite that second term because it's x to the first power. I'm going to bring the 3 along, but move that x up to the numerator. So it's x to the negative first power. Next, bring along the minus 4. Move the x to the 6 up to the numerator by using a negative 6 for its exponent. And then finally, strategically rewrite that square root. So the 5 came along, but it's going to be x raised to the 1 over 2 power because we have an exponent of 1 on the x, but then we have an index of 2 for a square root. So that's where the 1 over 2 comes from. It always goes exponents to the numerator, and the index on the radical is the denominator. Okay, next, let's go ahead and try to use our power rule to integrate. So when you do this, always bring along the constant out in front. So the negative 2 comes along, then we'll have an x, but then what we want to do is take the old exponent, in our case this one is 3, and we're going to add 1 to it. That'll give us our new exponent of 4. We're going to divide by that new exponent. I tend to put these out with the constants because they are constants. Then we'll move on to the next one. We'll bring along the minus 3. We want to have an x, but now let's think about what our new exponent has to be. It's going to be negative 1. We add 1 to that, and we're going to get 0 for our new exponent. But then we also have to divide by that new exponent. So at this point, bells and whistles should be going off. We're not allowed to divide by 0. So let's put a pin in this. This is going to be a special rule. We'll come back to that in just a second. All right, next, moving on, we have the minus 4 comes along. We've got our x. We're going to compute negative 6, our old exponent, plus 1 makes negative 5 for our new exponent, and we divide by that new exponent. Last term here, we have 5 comes along. We have our x, but now we have to figure out our new exponent. In this case, it's 1/2. When we add 1 to it, we may want to strategically write that as 2 over 2, right? So we have a common denominator. 2 over 2 is the same thing as 1. So 1/2 plus 2/2 is 3/2. Now, if we approach it like we did these others, we're going to be dividing by 3/2. However, we probably don't want to leave that as 5 divided by 3/2, so let's clean that up in just a second. To finish this line up, let's go ahead and put a plus c at the end because we did take the antiderivative of an indefinite integral. All right, next up, moving on down here, this term, we're going to clean it up a little bit. Negative 2 over 4 can be negative 1 over 2, x to the 4th power. Now, what about that special rule? Hopefully you remember no divided by 0, so we can't use the power rule in this case. Hopefully you remember that special rule involves a natural log of technically the absolute value of x. So the minus 3 comes along. All right, that was our constant. And then instead of having x to the 0 power and dividing by that 0, we're going to use natural log of the absolute value of x in that place to take care of the x to the negative first power or dividing by x to the first. All right, from here, there is a little bit more cleaning up we can do, but not much. Like instead of subtracting negative 4 over 5, we can add 4 over 5, x to the negative 5th power. Bring along the 5, instead of having 5 divided by 3 over 2, it's going to be more efficient to write multiplying by 2 over 3 instead of dividing by 3 over 2. And hopefully you're taking note here. The dividing by 3 over 2 is equivalent to multiplying by its reciprocal, flipping it upside down, multiplying by 2 over 3. It's just more efficient to do it that way. I'll go ahead and leave that as x to the 3 over 2 power for the time being. And let's think about any other reducing down or simplifying we can do. Well, this first term looks good. So we're going to leave it as is, minus 3 natural log of the absolute value of x. Here I'm going to go plus 4 over 5, but let's go ahead and get rid of our negative exponent. Not all professors require this, but it's using that same rule we used earlier. Associating a negative exponent with x in the numerator is the same thing as making it positive and moving it back to the denominator. All right, let's think of this as 5 over 1, so we can multiply numerators. 5 times 2 makes 10. 1 times 3 for our denominators makes 3. And then we could leave that as x to the 3/2, or if you were required to, go back into making it a radical. So this would be a radical of index 2, because that's our denominator, and it'd be x to the 3rd power. Now that 3 you can either put under the radical or on the outside of the radical. Either way means the same thing. So this is our antiderivative in the nicest form we can leave it in. Hope this helps out. Good luck as you're working through these.